Genetic algorithm. This video we are going to talk about the genetic algorithm in detail, like what genetic algorithm is, how it is called as an evolutionary algorithm. We'll also try to understand some basic terminologies like what is chromosomes, what is population, and we'll try to understand each and every terminology with the real time example. So basically, genetic algorithm is a search based optimization technique which is based on the principle of natural genetics and natural selection, or it is also called as a nature inspired algorithm, the algorithm which is inspired from the nature. Or we can also say genetic algorithm is based on the biological evolution process. So basically this is designed to solve the optimization problem. So what is optimization problem? Optimization problem is a problem where we select the best solution from the list of feasible solutions. Or one can also define the optimization as the process of making something better. For example, we want to improve something, like maximizing the profit or minimizing the error. So basically it finds an optimal solution, we can say. So this algorithm is based on the Darwin's theory, that is a survival of the fittest. So in biological evolution process, if you see the peoples in 1800th century, the peoples in the 1900th century, and the people at present, we can say each successive generations is better and better. So in biological evolution process, we can say the two people mate, they will produce a new child. So again the process continues, and we will have many such childs, but who will survive? The candidate or the child who is more fit. So each generation is considered as in one iteration, and iteration after iteration, so this generation improves, and hence we can say it as an optimization. And researchers have tried to implement, or they try to write the algorithm based on this biological evolution process, and hence they have come up with this very famous algorithm called as an genetic algorithm. Now let us see the evolution cycle of this genetic algorithm. So initially we have some population with us. So what is the population? Set up all feasible solution. In simple language I can say set up all feasible solution for a given problem we can call as the population. Now we need to find the best solution among these feasible solutions. For that, this genetic algorithm, how it works, we will see. So from these set of solutions, let us say we'll select the two solutions. So this is selected based on some, let us say, a fitness function. We'll calculate the fitness score for every solution. So from all the feasible solutions, we'll calculate the fitness score using the fitness function for each feasible solution. And let us say based on the fitness score, we'll select the two solutions. So these two solutions will act as a parents. Then they will go, or they will undergo the next very important state, that is called as a crossover and mutation, which will produce the new childs. So those new childs we can say as an offspring. So the two solutions selected from the population we can call as in parents. So these two parents will undergo the crossover and mutation phase to produce the new childs, a new offspring we can say, and again these new offspring will be evaluated based on the fitness function. So among the new members generated, so it may happen that some may not be the fitter one, so some members will be deleted and some members will be carried forward, so they will be a part of the populations, and this whole process repeats until some criteria gets satisfied, that is, we'll find the best solution. So that's how the genetic algorithm works. So very important step in the evolutionary cycle is crossover and mutations. So let's try to understand now this whole evolutionary cycle with one example and what exactly happens or how this crossover and mutation takes place to produce the new childs. Now let's try to understand this evolutionary cycle of genetic algorithm with example. Let us say I have numbers from 1 to 100. So from these numbers 1 to 100, let us say I'll generate the 4 numbers using let us say a random function. So these 4 numbers are, let us say, 29, 40, 59, 87. So let us say this is my population. Now from this population I need to select, let us say, 2 childs or 2 candidates. So for that I'll use the fitness function for the selection. So let us say I'll apply the fitness function. So let us say f of x is the fitness function. So I'll calculate f of 29, f of 40, then f of 59 and f of 87. And let us say I'll get f of 29 value as 0.1, f of 40 I'll get value as 0.4. For this f of 59 I'll get value as 0.3, and for this f of 87 I'll get value as 0.2. So from this I need to select the 2 candidates, let us say 2 solutions. So based on the fitness function and fitness score, I have to select these 2, f of 40 and f of 59, based on the fitness score. So this 40 and 59 will go to the next step. So these 2 are going to act as my parents. So these 2 will meet with each other and undergo the crossover and mutation phase to produce the new offspring. So let us say those new offsprings are 47, 71, 89 and 91. So again, so these new childs will undergo the evaluation phase. So again I need to apply the fitness function over this 47, 71, 89 and 91. So I need to calculate f of 47, f of 71, f of 89 and f of 91. So based on the fitness score, so some candidates may not be fit, so those members will be deleted or discarded, and rest will go to the next stage, that is population. So they will be a part of population, and this process continues till some criteria gets satisfied. So this is how genetic algorithm evolutionary cycle takes place. Now let's try to understand some terminologies in genetic algorithm. So what is this chromosome? So this chromosome we can say as one possible solution which is part of your population, you can say. For example, if you consider your 0-1 knapsack problem, So what is this problem? So we have one bag called as a knapsack, and we have some object with some weights. So we need to put all these objects into this knapsack. So knapsack also has some capacity. So we need to select such objects such a way that their total weight should not exceed the capacity of this knapsack. So which objects to be selected so that we will get the maximum profit? So this is one solution, one possible solution for putting objects into the bag or knapsack. So what does this 0 1 0 1 1 indicates then? So this solution is represented using a binary encoding. So we have, let us say, 5 objects. So 0 means first object is not selected, 1 means second object is selected, 0 means third object is not selected, this 1 means fourth object is selected, and here 1 meaning is fifth object is selected. So second, fourth and fifth object can be selected, and they can be put into the knapsack and will get the maximum profit. So this is one solution. Again, so 1 0 1 0 1 can be another solution. So using this solution also will get some profit. Like in the second solution, first, third and fifth objects are selected and they can be put into this knapsack and will get some maximum profit. Or will get some profit. So like this we have many such a solution, and we need to find out the best possible solution so that we will get the maximum profit. And each such a solution we can say as an chromosome, and set up all such a feasible solutions we used to call as an population. So each bit, let us say this one, so each bit is called, or this corresponds to a gene. Each bit in chromosome is called as a gene, and allele is a number or a value of gene. So let us say for this gene the allele is 1. Now we have the population with us. So each solution we used to call as in chromosomes. Now we need to understand how these chromosomes will undergo the important stage, that is crossover and mutation. So how this crossover and mutation takes place on these chromosomes, we'll try to understand this by an example. Now let us understand this crossover and mutation. So let us see single point crossover. Suppose I have two parents, parent 1 and parent 2. So these two are selected based on the fitness score, let us say. So parent 1 is 0 1 0 1 1 0 and parent 2 is 1 1 0 0 1 1. So these are shown, or chromosomes we can say, these chromosomes are shown using the binary encoding scheme. Now these two parents will meet and will produce the new child. Let us say they produce the two childs. So how this crossover, single point crossover takes place? So single point crossover meaning is we have one crossover point. So let us say here we have crossover point. Similarly in parent 2, after 3 bit we have the crossover point. So how the new child get produced? So this 0 1 0 will be as it is. From the parent 2, this 0 1 1 will go here, 0 1 1. And how child 2 will be produced? So this 1 1 0 will remain here, and this 1 1 0 of parent 1 will come here, 1 1 0. This is how the child 1 and child 2 gets produced, and we will get the new childs. This is a single point crossover where we have only one crossover point. So there can be 2-point crossover. So now in 2-point crossover, we have 2 crossover points. Let us say here and here. Similarly for parent 2, here and here. How the childs gets produced? So let us say this 1 0 will remain as it is, and from parent 2 this 0 1 0 1 will come here, and this 0 0 will remain as it is. This how we will get the child 1. How will we get child 2? This 1 1 will remain as it is. This 1 1 from the parent 1 will come here, and the 1 1 from the parent 2 will remain as it is. So this is how the crossover takes place. Now how the mutation takes place. So in mutation, just bit is inverted. For example, we have parent 1 with the code 0 1 0 1 1 0. So this bit, let us say second bit is inverted, so meaning is this second bit 1 will be made as 0. So this is how the crossover and mutation takes place, and we will get the new childs. So how this genetic algorithm works? So initially we have the population with us, so that is what the initialization phase. Then from this population we need to select some individuals for mating, we can say. Then in crossover and mutation, the two individuals we can say mate, and they will produce a new children. And once we have the new childs, we should insert these new childs into the population, and then we'll check whether our criteria is satisfied or not. If yes, then we'll finish. Otherwise, again we need to go back to the second step, that is select the individuals for mating based on the, let us say, the fitness function. So this is how the genetic algorithm works. So this genetic algorithm has wide applications in every field, not only the computer science. It can be applied in mechanical also, it can be applied to the structural engineering and so on. So very simple example I can say, if you have a data set, and in the data set some features needs to be selected for prediction or classification, let us say. So which best features can give us better prediction accuracy, let us say. So for that we can apply the genetic algorithm, and each step the new feature will be extracted and its accuracy, prediction accuracy can be checked. So these genetic algorithms are very much helpful in such scenarios.